In this example, we're going to construct a confidence interval for a population mean when sigma is known. So we have in this example a study of the ages of motorcyclists killed in crashes that involves the random sample of 150 drivers with a mean of 37.1 years of age based on data from the Insurance Institute of Highway Safety. We're going to assume a population standard deviation of 12.0 years, and we're going to construct a 99% confidence interval estimate for the mean age of all motorcyclists killed in crashes. So in this example, we first want to identify the given values in symbolic form. So as we start reading, I see 150. That is the sample size. So sample size we label as N, and N is 150. There are 150 people in the study, and it's saying of those 150 people, the mean age of those drivers, so that is a sample mean, is X bar, is how we label sample mean, and that's 37.1 years of age. And then we're going to assume a population standard deviation. So we give that symbol a sigma, and that is 12.0 years. So I'm just going to label that as 12. And then we're going to construct a 99% confidence interval for the mean, mu. We're going to label that as mu for the mean age of all motorcyclists. So we're using the sample data to infer to the entire population. And when we do a 99% confidence interval, that means that we're going to draw our bell-shaped curve. And when we draw our bell-shaped curve, we're going to put 99% of the data in the center, or 0.99. And then alpha would be 1 minus 0.99, because the whole totality of the curve, area under the curve, is 100% or 1. We're going to take alpha is 1 minus that, the totality of these two tails, and we would get 0.01. Now we're going to split that equally into the right tail as well as the left tail, because we could be wrong on the right side or wrong on the left side. So we're going to split it equally, 0.01 divided by 2, and we're going to get 0.005. So we'll get 0.005 on the right tail as well as the left tail, and that's the area under the curve on those two tails. Now we're going to use that Z critical value like we had before. We're going to look up 0.005 in the right tail, or by symmetry that left tail. So we're going to bring back our Z table, and again the first column, first row is the Z square, the whole number, and the first decimal place is that first column, the second decimal place is that second row. So we're going to look in the body of the table because we have a probability or area in the right tail of 0.005. So we're going to look across the rows and get to the closest or exact, and I find 0.005 is equally distant between these two numbers. So you'll see it shoots me down to the bottom of the table, and it says for an area of 0.005, I'm going to get a Z-score of 2.575. So we're going to use 2.575 in that right tail and the negative 2.575 in that left tail. So that is going to be our Z critical value. So anytime we see Z alpha over 2, we're going to have that plus or minus 2.575. So when we construct a 99% confidence interval for mu when sigma is known, sigma is given to us, we would use the formula as X bar plus or minus Z alpha over 2 times sigma over the square root of n. So we're just going to plug in all that information into the formula now. So we always want to identify the given values first, find the confidence interval formula that we need, and then we need that Z critical value, so we found that. And then we're just going to plug in. I know X bar is 37.1, that's what we got. The plus or minus comes from that Z critical value, 2.575. We're going to multiply by sigma is 12 and divided by the square root of 150, that's n, our sample size. So when we calculate out, we're going to take 12 divided by the square root of 150 and then multiply by 2.575. I'm going to get this number. This is called the margin of error. So we get 2.522974435. That is called the margin of error. So when we take the Z critical value times this sigma over the square root of n, that's called our margin of error, and our point estimate is the X bar. So we always take the form is the point estimate plus or minus that margin of error anytime we set up confidence intervals. So when we calculate the lower limit, we're going to take 37.1 minus 2.522974435. And when we do that, we're going to get 34.58. When we do the upper limit, we're just going to take the addition of that. So we're going to take 37.1 plus that 2.522974435. And when we do that, we're going to get 39.62, just rounding. So when we calculate that confidence interval, the way we write it, we have that lower limit number. The way we write that confidence interval for the 99% confidence interval is written as, we're going to write that 34.58 lower limit number in years. That's our years of age, 34.58 years, less than mu, less than, and then that upper limit, 39.62 years. And that's saying that in overall our population mean, 99% of the time should fall between these two numbers, 34.58 and 39.62. So I didn't have to go out to the entire population. I can use these 150 to estimate the overall population of what it would be. And we can be 99% sure that our mean age of motorcyclists killed would be between 34.58 and 39.62 years of age.